Hi, this is Callan Bentley. Welcome back for another Smart Figure. After watching this video, you should be able to describe the relationship between flood basalt provinces on Earth's surface and the hotspots that we think produce them. This is a map showing the various flood basalt provinces on Earth. You can see that some of them are located on continental lithosphere, like the Siberian Traps, or some of them are located on oceanic lithosphere, like the Ontong Java Plateau. Some of these flood basalt provinces are associated with hotspot tracts. Like over here, we find one example in the Pacific, there's an example in the South Atlantic, and the Galapagos Islands even have a relationship to an oceanic plateau. So let's take a look at what's going on here. First off, the flood basalts themselves. These are areas where huge stacks of basaltic rock build up when lava erupts from fissures in the Earth's surface. So fractures open up, lava fountains out of those fractures, it spews out into the air and then oozes over the landscape, flooding it. You can see the edge of one of these flood basalts, the Columbia River flood basalt province, here in the lower left image. So in this case, the source for the lava was on the left, and then it flowed towards the right over time. Some scientists are convinced that this has to do with mantle plumes and the hot spots that mantle plumes leave behind. Now, these mantle plumes are rising bodies of warm rock in the mantle. They rise because they are less dense than the surrounding cooler rock. They have a relatively wide head region and a relatively thin tail region. Where do they come from? Well, if they exist, it's not entirely certain. Some people have suggested that they come all the way from the core mantle boundary, that the mantle rock there warms up, takes heat from the core, and then rises up through the entire mantle to finally interact with the lithosphere up above. That's one possibility. Another possibility is that warm rock leaves the mantle, travels up partway through the mantle, and somewhere it stops, interacts with the rock above it, and there the melting is triggered and you end up getting volcanoes. Another possibility is that mantle plumes are actually sourced in the very shallow mantle and that they don't actually have anything to do with the core mantle boundary whatsoever. Regardless of where they come from, we think that what happens is they rise up through the mantle, moving up towards the base of the lithosphere, and then interact with the base of the lithosphere, causing many large eruptions of basalt. So if this is through the oceanic lithosphere, as is shown here, this is all happening underwater. These would be pillow lavas. If this is happening out in the open air on top of a continent, then you end up getting those floods and fissure eruptions. Regardless, though, you build up a big, thick stack of basaltic rock. Plate tectonics carries that big basaltic province off